Okay, good. All right, that's the most important part. Hi, my name is Alicea. I'm an evangelist at Unity Technologies for games and media entertainment. So basically, I love all the cool stuff happening in video games, animation, film, and more. I come here all the way over from San Francisco, California, and I ask you to forgive me throughout this presentation today while I take a couple of breaks because I caught the worst cold here. So but I didn't fly all the way to Singapore to not present. So I'm here to give my talk, and then just bear with me as I take water breaks and such. But I'm also couldn't not miss doing this talk because it's my favorite tool in Unity right now. And I'm here to talk to you all today about Unity's visual effect graph. So who here has used the visual effect graph before? Raise your hand. Okay. One guy there, you get a high five. You're awesome. So this is cool. I'm going to keep it then a little bit low level, so that way, more covering the basics of the visual effect graph. But let's go ahead and jump in. Oh, one thing I actually do want to show you before I start. Notice that my PowerPoint isn't PowerPoint, it's Unity, right? My slides are actually live right now in the Unity editor. And everything that you're seeing are live visual effect graph examples running in real time from the editor. These aren't videos, these aren't GIFs. These are actual special effects made in Unity with the visual effect graph that you're seeing as I'm presenting. So just keep that in mind as I'm going through each slide. Now we'll begin. So what exactly is the visual effect graph? It's the next generation visual effects tool in Unity to create special effects without having to code. It has a stack and node-based kind of hybrid system, so you can be able to drag and drop different nodes together to build up your special effects. But it's also programmable, and you can access this through your code and such as well. Now, it operates as a self-contained asset file on in your Unity project. And it has an event and parameter interface, which means that you can expose values in your visual effect graph to be easily visible and editable in your inspector or through your code. And right now, the visual effect graph is tailored to support platforms and devices that support GPU compute. So this is going to be your more higher-end devices, your nicer PCs, your Xbox Ones, PS4s, maybe like really advanced mobile phones. And setting up the visual effect graph is incredibly easy. All you have to do is go to the package manager. How many people here are familiar with Unity's package manager? Raise your hand. Okay, a lot of you, good. So basically, then you know the drill. You go to Window, Package Manager. You open that up, you get a window like here below, and you can download the visual effect graph to use in your projects. Now, keep in mind that right now, it's using the scriptable render pipelines in Unity, and I'm sure you've heard a lot about those throughout this conference. And right now, there's full support for the HD render pipeline, and there is support for the universal render pipeline supporting unlit particles only. And I'll share some updates about what's coming up for the universal render pipeline as well. But make sure you download the URP or the HDRP because you'll need one of them to be able to use the visual effect graph as well. And another pro tip I have before getting started is to go into your project settings. You'll see a specific area for visual effect graph. Go ahead and check off Enable Experimental Operators because that will give you access to cool experimental nodes like GPU events. Now, key points about the visual effect graph. This is a very artist-friendly tool. How many people here are technical artists? A couple? Cool. So this workflow is actually going to be very familiar to you because we created the visual effect graph keeping other kind of workflows in mind that technical artists are already used to. Now, we're able to have so many cool effects and basically so many particles in our visual effect graph because we're using GPU-based particles. And I'll go into a bit why that's special in a moment. The visual effect graph is also great for scalability of effects. So you can use this for anything from, little puffs of smoke to a huge giant explosion and crazy weather and more. There's lots of different things that you can do with the visual effect graph, all very performant. And kind of like I mentioned, following industry trends, we want to make sure that this tool is aligned with workflows that you're familiar with similar node-based systems, kind of like Unity. So that way it's kind of a more easier tool to jump into and learn and experiment with. And lastly, like I also mentioned before, this takes advantage of the scriptable render pipelines in Unity, so that way we can achieve some really gorgeous looking graphics with the visual effect graph, especially when we're using the HD render pipeline. Now, I mentioned earlier that this is, using GPU particles, but what's the difference between GPU-based particles in the visual effect graph and CPU-based particles, which make up Unity's original particle system? Well, there's pros and cons to each, and depending on what you want to do for your experience, you may want to use one or the other. So with the original Unity particle system, you could have thousands of particles in your scene at once. But with the visual effect graph, you can have millions because we're unlocking the power of the GPU. Now, with doing simulations and stuff and more in physics with the original particle system, the CPU-based one, it was pretty simple and straightforward. There's also kind of like lots of different options that you can have to do with it. But with the visual effect graph, it gets a little bit more complex to be able to kind of do those simulations. But on the other hand, you can create really complex, intense looking simulations like fluids and more. And I'll kind of illustrate this more in some examples I'll show later. Now, benefits to using the original particle system. Underlying physics system. So basically, because the visual effect graph particles are on the GPU, and all of Unity's physics happens in CPU land, it's a little bit harder for the visual effect graph to talk back to the CPU, because then we lose all that performance. So if you want to have your particles kind of really take advantage of physics and such, then you still might want to use the original particle system. You can do physics with the visual effect graph. Right now, you would have to use things like primitives, sign distance fields, and depth buffers to be able to control the physics that way. Now, the original particle system also gives us gameplay readback. So if you want your particles to affect your gameplay, it's good to use the CPU-based system. You can do this with the visual effect graph, but you're going to have, you can probably do it with a small amount of data, but you're going to have some latency. And then another benefit of the visual effect graph is that you can use it to ready frame buffers. But what exactly does a visual effect graph look like, and how do you make one, right? So first, for visual effect graph, you have three main components that are used throughout the graph. The first important part are the contexts. Now, the contexts are basically what carry all the kind of different blocks and behaviors that make up your visual effect graph. But empty alone, they don't do anything, but rather they dictate the phases that those behaviors happen in. So you have your spawn behavior over here, which dictates what happens, how are your particles spawning in your scene. Then you have initialize, what happens to your particles in your scene on start. We have update, which is behaviors applied to your particles throughout updates. And then you have your outputs. And there's lots of different kinds of outputs, but really what they all do is just determine how is the particle actually rendered? What does it look like in your scene? Now, blocks is where it's kind of like that magic starts to happen. These behaviors that you add to your context to start building up your visual effect. So here, for example, we added in, constant spawn rate, saying the size of the particles, saying the color, and more. This is where you put all of those initial behaviors in each pass of the context to make your effect. And nodes are what you add to blocks to really customize and fine-tune those behaviors and get very specific on how you want them to operate in your effect. Now, supported file types. I promise that's not a warning. I just thought the skull looked really cool. But the visual effect graph supports assets that allow you to represent volumes, forces, collisions, and so on. Right now using point cache data, vector fields, and sign distance fields. And for those of you who are technical artists and work in Houdini and such, those file types are probably more familiar to you. You could bring those in from your program and put them into Unity to use in the visual effect graph. But instead of me telling you how cool it is, let me actually show you how to make a very basic visual effect graph from scratch. Sound good? Cool. All right. So here I have a blank Unity scene. This is a HDRP project. The only thing I have going on is just a procedural sky in the background to make it just, solid gray so we can see our effect a lot better. Otherwise, there's nothing else in this project, and we're going to build this visual effect graph from scratch. So the first thing I want to do is I want to go to my assets folder, and I want to right-click, create, and go to visual effect graph. Oh, I left my glasses today. I shouldn't have done that. There we go. I'm going to call this Unite Singapore. And there we go. So now I've opened up my visual effect graph, and I'm going to drag it into my hierarchy. And now we see my effect right here. So whenever you create a visual effect graph, you're sorry. When you create a visual effect graph, you're always going to have the same default template created each time you create a new asset. So right now we're seeing the Unity default for the visual effect graph. And what we're going to do is, to keep this simple, I'm going to modify this existing template so we can understand how these changes work and are applied to our visual effect graph. So the first thing I want to do is I want to go ahead to my spawn right here. And right now I'm spawning 10 particles per second, but I want to make that 25,000. Now there's no change, right? Because what we also need to do is adjust the capacity of what our effect can hold, how many particles at once. Right now the capacity is set to 32 particles, but we want it to show a lot more. So I want to make the capacity of the effect to 65,500. There we go. So I have a bunch of particles that I can now play with, kind of spawning in this cubish shape. Now, I was thinking about the effect that I want to kind of make here. Again, something really basic, but I think I want to make a ball of sparks. So I want to kind of take all these particles that we have, make them a spherical shape, and then have them kind of like flare out a bit, as sparks do. And then at the final part, make the particles actually look like sparks and not the kind of little odd default clock image that Unity applies. So how do we go ahead and start making that kind of ball of sparks? Well, now that I updated my capacity, I want to slightly adjust the bounds. I want to make sure the center here for my effect. And I'll make it slightly bigger, the bounds of where it's spawning. Now I want to go ahead and remove set velocity random because I don't want to apply random velocity. I want them to form a specific shape. So I can just click on the node, the block, and just press delete, and it's deleted from my my effect graph. Now you can see all my particles are still here, but they're all spawning down below. Now to add a new block, I can click on my context, my initialized context. I can right-click. I can add something that way, or I can press space, and I can get this really nifty context-aware menu that I can type in the block that I'm looking for, and it'll search through all the different blocks and behaviors there are and add the one I need. So in this case, I want to add position sphere. And now what that does is basically take my particles and position them all along the edges of a sphere primitive. So here I have kind of my nice little round ball of my particles. All right. Now the next thing I want to do is that on update, I want these particles to, again, like flare out, right? And I want that to happen throughout every frame of the effect. So I actually want to apply a force to these particles on update. So I'm going to scroll down to my update context. And I'm going to go click here, press space. And I'm going to add a vector field force. Now, this is actually using a vector field file, which Unity will give you one by default, and we're going to use this default vector field. But if you have like vector fields that you've made in other software, let's say, you can absolutely bring those in and drop them in right here into this vector field section right here. Now, what I want to do is actually, we can see subtle changes happening, but I want to up the intensity of how they're moving along this vector field by 12. And now we can see my particles are kind of like flaring out a lot more. Now, next what I want to do is change how these particles look. So, like I mentioned, the quad output, you can determine how your particles are rendered. So in this case, I want to, I want to go ahead and make these sprites look like sparks. So the first thing I want to do is change the blend mode. And for those of you who are artists here and have used things like Photoshop, a lot of the settings for your output are going to feel very familiar. So I have my blend mode, and I could set it to additive. And it gives me a nice glowing effect to my particles. The next thing I want to do is change the texture that I'm using. Right now it's using the default particle, but I want to go ahead and use this little sparkle particle I have here. It's really just kind of like a dash of white that fades out at the end. And now I have my sparkle texture applied. Now it's currently using the settings that were applied for the original kind of round particle. So what I want to do next is kind of change the sizing of these sparks so that they look like actual sparks and not like little smudges. So the first part here I want to do is I want to, right now they're oriented to face the camera plane. What I actually want them to do is be oriented along velocity. So basically by saying oriented along the camera plane, if you have this in a game, let's say, and you're walking around your effect, the particles will always turn to face you. And so in most cases, especially like in a kind of game-based case, you want that because you don't want to kind of go by and see kind of your just particles disappear because you're looking at them from the side. But in this case, I actually just want to make them follow the velocity that they're being pushed in by the vector field force. So now they're going to face different directions as they're being pushed by that vector field. Now I want to get rid of set size over life for now. I just want to set the overall size. I'll set the size to 1. And now I want to set the scale of my particles. So I'm going to add set scale. And I can pick specifically which channels I want to work with. And I could either set scale across the X, Y, and Z axes, or in this specific case, I just want to adjust the X and Y scales. And I'm going to make the X scale 0.06 and the Y scale 0.75. There we go, they're looking a little bit more spark-like. So I could adjust them with these sliders to see how I can kind of get that effect. And notice how as I'm going through this, all these changes are happening in real time in my scene. So it saves me a lot of time so I don't have to kind of like compile it or more and then go back and see how it looks. So let's see. Yeah, I like how that looks. So, all right. Now, I also want to set the scale of the Y value over life. And basically what this means is over the lifetime of the particle, I want its scale to change. So I want it to basically fade in to the effect, and at the end of the particle's lifetime, I want it to fade out again. So to do that, I'll just set my channel to the Y channel, and I'll open up this curve graph I have here, and I could manually edit these points. I can use any of these presets here, and you can see how each one affects the effect. In this case, what I want to do is I'm going to make a straight line. I'm going to right-click right here and add 2 keys. I'm going to multi-select these 2 at the end and bring them down. Oh, I selected all of them. Well, here, I'll do this. I'll bring these up. And I'll bring these down past 0. So here, what I'm essentially doing is I'm saying, okay, and if I bring it lower, you can kind of see it, right? See how the particles are fading out now as they kind of reach the end of their lifetime? So there we go. I like that. So now that we have kind of our sparks flying around and then, they're fading out, the last thing I want to do is actually make them look fiery, right? Give them some color, some life. So I'm going to go ahead and go just in this color alpha over life here. I can specifically set new colors. I can double click these little tabs here and give it a reddish hue at the start, an orange hue here at the end. I can tinker around with those colors as much as I want. I have a preset gradient I made here. I can adjust the intensity of the colors, so I think it looks really bright here. I can move this around. But basically, there you go. So now we have, in just a couple of steps, maybe 8 steps that we took together right now, we have a simple, cool-looking fireball effect in Visual Effect Graph. Now, there's different ways that you could use this, right? You could have this be a star in a sky or a sun, or you could have this be a power-up for a character. And I've even seen people kind of like zoom in and put something in the middle and have it be like a transformation, like anime type sequence thing. Lots of flexibility with the things that you can do with the Visual Effect Graph. So I want to show you now some kind of other examples of what some more advanced Visual Effect Graphs look like. All right. You saw this example in the beginning of my slides. Basically, what we have here is some particles being spawned by that sphere that's kind of flying through the scene. And they're being attracted towards a volume of the Unity cube here in the project. There's like 400,000 particles in this example. I like this volumetric fluid example because it's an example of really taking advantage of HDRP features outside of the visual effect graph. So we have volumetric lighting here. We have the 2 spotlights. We have some volumetric fog. And basically, in addition to the particles that we have here, creates that really cool volumetric fluid looking effect. And we're actually using Flipbook for these particles. And I'm going to show you another example of what Flipbook is and explain that in a moment. Here's some pretty fireworks. I like these. And again, ways that you could use lit particles and have even the reflections down here in the water. And this is all visual effect graph, I think, except maybe the moon. Again, different kind of fluid simulation where you can have lots of little kind of round balls moving around. I really like this example because a lot of people think of visual effect graph and go like, cool, I can make explosions and like, external things like in the sky or whatever. You can also use it for characters. Like this reminds me of like those really annoying enemies in Legend of Zelda that would always kind of get you with their lasers. But this is a kind of contextual example of how you could use visual effect graph for a character. So a new feature, and I'll talk about this too later, but that's coming up with the visual effect graph is the ability to do ribbons and trails and more, stuff like this. I see people make cool things like vines using this effect. This AR, I love this AR radar. It's 100% visual effect graph. basically we have a lot of different systems within one visual effect graph that are, for example, spawning the dial on the bottom, that kind of, net that popped out, and also those enemy ships that are on the radar. And it also interfaces using Unity's timeline. Cool line renderer. And really, I show you all these examples so you can get some inspiration of what you can create. I love this example because it's so simple. It's basically a point cache data scan of somebody's face, and we're applying a particle to every point in that point cache data, and then at the end of that particle's lifetime, we're simply changing it to another particle. It's one of the most simplest graphs out there, and it looks super cool. You can even make it look pretty creepy. We made this bubonic face. Really all we're doing is spawning spear primitives on each point in the point cache data, turning them orange and applying gravity to them and pulling them down. And that's it. Really simple, looks really creepy. Perfect. Happy Halloween. This plasma core effect, I want you to remember this one because I'm going to tell you later, I'm going to show you something and I want you to remember back to this point. But again, like more cool effects. Let's see, what else do I have? I like this portal one. And how the sparks bounce against like the tiles at the bottom. It's so nice. Smoke. Actually, this is my favorite example of what flipbook is. So you can actually take sprite sheets like you would use, like let's say in your 2D games. You can make a 2D sprite sheet of particles. In this example, we're having a sprite sheet with, I think it's like 64 sprites of smoke, different smoke patterns. And we're using flipbook, which is a node in the visual effect graph, to play through that sprite sheet as the for the particle. So as each particle is being spawned, it's being spawned as a smoke sprite, and then it being animated through that sprite sheet throughout its lifetime. It's a cool little ink splash of our logo. And I think I'll leave it at there for now. So I'm going to show you one more example. All right, let's see if I have audio. So this is the spaceship demo that Unity created. This is an actual game example of a project using visual effect graph throughout the experience. And I'm actually playing like now in real time, like moving around, and once this door opens, you'll see. So it's me looking around. That blue overlay, those pipes, those are all visual effect graph effects. That steam coming out of those pipes, those sparks out of that light. This whole interactive overlay that we're about to see.
Check in progress.
Always facing me as I walk around, using that face of the camera plane.
Granted.
Good to see you well.
And this is one of the most beautiful examples, I think, out there of the visual effect graph of the space, like the holo table. This is an interactive map with thousands of little particles that, as we approach, will all show us different little maps and such in space. This is all done with the visual effect graph. So right now, I'm on this spaceship. Something's wrong. I gotta figure out what to do. I want to find a new planet to go to park at for a bit. I gotta look at these different planets, figure out where to go. But before I do, I also want to show you one more example. Isn't this pretty? So I love this visual effect graph because one thing that, hold on, sorry. Oh. One thing that I often hear from people is that we want to use the visual effect graph, we're really interested in it, but we have no idea how to get started, let alone create super big crazy effects like that. And my answer to that is it's definitely doable. Because remember that kind of like the ball of sparks that we made, let's say? or that different kind of plasma core I told you to remember, that's basically like very similar to what makes up that middle nucleus of this effect. Those lightning bolt effects, those blue kind of streaks of lightning, those are incredibly simple to create a visual effect graph. We're basically determining 2 points and then just spotting like a line of particles between them. Those rings of kind of flames that are swirling around are basically just that. It's just a swirling ring. But you layer all these effects on top of each other and you get a really cool effect like we see here. So whenever you see a visual effect that you think is really interesting and you want to recreate it, just think about it in smaller little components and how you can layer those together to create an effect just like this. So let's get out of this spaceship. All right. All right. Barren Earth. Inhabitable. I guess we'll go there.
There it is. Hurry up, we don't have much time.
Landing target located. Attention. Multiple weapon signatures
I did something wrong.
detected.
Okay. And I'm gonna die now probably.
Incoming.
But the again, all this visual effect graph, like I love this. I love that we can have the ship spawn there and see the kind of fog and everything. And there's so much that you can do with the effect graph to create really cool, not just effects, but really like moods and setting the tone of your games or film experiences that you're working on. And so, yeah, I'm not gonna make it. So that's I think that's the end of my spaceship.
Immediate evacuation. Proceed to the tenders now.
Yep. All done. All right. Pretty cool though, right? So I want to share a couple of final things with you before I wrap up my presentation. All right, so for those of you who maybe have been keeping tabs on the visual effect graph, we released it early this year, but we've since released a bunch of new updates to it, and those include subgraphs, the ability to save different sets of blocks and nodes and more in your effect graph to use repeatedly. Saves you a lot of time because let's say you're working on a game where you want to have different kinds of the same effect and you're building out the same initial first couple of blocks. You could just save that as a subgraph. And you know when I had that searchable menu and I could search for a specific node, you could also search for subgraphs that way as well. Really saves you a lot of time when you're developing your effects. We are also going to have, we also do have shader graph integration for the HD render pipeline. So you can have shaders apply to your particles, the visual effect graph. We also have a per spotter loop and delay. This was a very kind of requested feature that we heard about. But basically, being able to determine not just like, hey, spawn these particles, but being able to tell your visual effect graph, you know, how many times to trigger this spawning, you know, is there a delay? Is there, you know, different kind of settings for how those are spawned? And then also motion vector support, which gives you a really nice blur effect to things that move very quickly, like sparks or more. And this can be enabled with just simply a checkbox in the visual effect graph. We also have the VFX toolbox. So if you're interested in the flipbook 2D sprite stuff I mentioned, you're going to find more tools to help you with that through the visual effect toolbox. And for those of you who are technical artists, we also have external DCC or digital content creation tools in the visual effect toolbox as well. So this includes plugins for Houdini, so that you can export your effect data from Houdini and bring it right into Unity for your visual effect graphs. Right now, the VFX Toolbox is available through GitHub, but it will soon be available as a Unity package, and you can get it through the package manager. We're also going to release more digital content creation tools for integrating with software like Maya and Blender. We also have motion vectors, for the image sequencer. And we're also adding support for vector fields, side distance fields, and flow map painter. Now, what's coming up overall for the visual effect graph roadmap? Now, in 2019.3, later this year, visual effect graph is out of preview, so it's production ready and you can use it in your projects later this year. We also, we're going to officially release the shader graph for the HDRP particles. And also particle strips. So like I mentioned before, trails, ribbons, and more, that's coming in Unity 2019.3. In the future, we're currently working on shader graph integration for the universal render pipeline. We're also working on having CPU-based particles as well through the visual effect graph. And we're also going to release universal render pipeline support for lit particles. But still, this would be for compute devices only. But other than that, that's about it for me. If there's any photo that you should take throughout my presentation, it's of this slide right here. Here's a bunch of my favorite resources for learning the visual effect graph. So that link up there at the top is for general info, about the visual effect graph, how you can see updates and more. Now, I have something fun to share with you all. So a bunch of those effects that I walk through, including that holo table and that spaceship game, you can download it right now and play with them in Unity through the visual effect graph samples. So you can download them all through GitHub on that link and have fun creating your own visual effect graphs for your own game projects. You can download the visual effects toolbox through that link right over there. And we have several really good blog posts about the visual effect graph on the Unity blog. This one here is my favorite because it's a really detailed blog post about how to really integrate your visual effect graphs into your game in the context of Unity's FPS sample game. So they're specifically going about how they use these visual effects in their networked game. They get really, really into it. It's a fantastic resource. If you read it and you want to read more stuff like that, just search for visual effect graph on our blog and you'll find a lot more posts. And lastly, hashtag visual effect graph. If you're on social media, we have a lot of artists in our community who are sharing their creations of visual effect graph through that hashtag. So feel free to check that out to find inspiration. Or if you make something, then you could share it there too. And we'd love to check it out. Myself and other Unity staff members like to keep an eye on it. But I'll be around for questions. I think I have a little bit of time, but thank you so much.